Oh, there we go. Tablet was acting up for some reason. Evening. I would like to make a revision on my Electrophorus videos, my last three. Apparently, the majority of my information was wrong, probably because I was panicking. First time I've ever done something quite like it. But now that I've had more time to contemplate and ponder over what exactly happens, I think I can explain a little bit better and correctly this time. What I missed last time, or before all that, the four things I'm going to be talking about: insulators, conductors, induction, and grounding. Now, insulators. Like I said before, the styrofoam cup and plate are insulators. What I didn't say is that this does not determine what charge they have. It does determine what happens to those charges. Everything that I am using in this experiment, project, whatever you want to call it, has both positive and negative charges, myself included. The styrofoam plates and cups, however, they have charges, but they're not allowed to move. Like before when I said insulators, like my hair and styrofoam, use the air to trap the heat. The air in the styrofoam also traps the charges. And what happens there is that since the styrofoam traps the charged particles, we need a conductor to get those particles moving. Now, that's saying those particles in the styrofoam will not move. They won't. What happens is that when we get this aluminum plate, disregard this straw for now, when we get this aluminum plate in the equation, after we're done rubbing this with a wool sock, the styrofoam plate becomes mostly negatively charged because the negative charges from the sock are put on this plate. Now, they can't move now that they're here. However, when I put this plate on the styrofoam, all of a sudden the two are attracted. This is where induction and a conductor come in. A conductor, like this aluminum pie plate, has charges same as the styrofoam, positive and negative. However, the charges can move in this material because it is a conductor. That's why it's so important to have aluminum foil in this experiment. These two are attracted because the positive charges go to the center of the plate and attract to the negative charges in the center of this plate. Now what happens there is if I try to pick it up, it's not charged right now, but as you saw in the video we watched in class, when it gets charged, let me put this light toward me so I get a little bit of lighting. I don't know why it just went red. What happens is that when you pick it up, or when the man picked it up, the plate was still stuck on and then it dropped. That's because the electromagnetic force is greater than the force of gravity. Another thing is that the negative charges, since the positive charges are here and the negative charges are in here in the plate, negative and negative repel each other, so the negative charges are now found in the rim. Hence the shock I get when my finger gets close to it. The negative charges from this go to my finger. Now, back to these two plates. The process that takes place here is called induction. And induction, in a physical and electromagnetic definition, according to Merriam-Webster, induction is the process by which an electrical conductor becomes electrified when near a charged body. Conductor, charged body, electrified. That's how the charges take place here. All the negative charges move here, and that is also the reason why we'd never pick it up by the plate. We wouldn't be able to feel the shock. Though the charges would be transferred to our fingers, it would also just reside there because we're not disconnecting. This plus this, not good. This plus this equals good because only certain types of styrofoam can carry a static charge that will shock me. Only certain types, and that static charge is very small. That's why we grab it by the styrofoam cup. because we can't get shocked. The electricity can't be drained out of here into my fingers. Now, another thing is that when we pick this up, the charges don't automatically go to the ground like I previously said before. They still reside in my finger. Some of it does. Now, since I am both positively and negatively charged and very handsome, I'm just kidding. Or am I? Anywho, since I am both positively and negatively charged, some of these negative charges I can put back into the plate when I hold the styrofoam cup, and the plate becomes charged again. Until I put it back on here, and the process can repeat where I shock myself here, I shock myself with it airborne, and so on and so forth. So, I covered induction, insulators, conductors, and... No, I did not cover grounding. Good thing I kept a mental checklist. Everything in this experiment is grounded. The thing is grounded on my desk. Otherwise, we'd have a bit of problem with the air being both positive and negative. And hydrogen particles are positive too, so we would have had a bit of a problem with the experiment in midair. But anywho, if I skip the last additional step and don't recharge this thing in midair, what happens to the charge? It flows through my body. The extra negative charges have to flow through my body because I have to be a balanced charge for my existence to continue, I suppose. I don't know that for sure. If someone can double check that for me and put it in the comments section, hey, more power to them. Especially you, Mr. Fork. Stop correcting my pronunciation and actually correct something else. Alright. Mr. Fork's the guy who comments on my videos. But the charges go through my hand, through my body, towards the ground where it can disperse. Alright, in part 2, I will add the straw in the tinfoil ball and explain that. But for now, I will upload this and pray to God that it actually uploads, because I have had to retry this 3 times, and the uploads have failed. So, wish me luck, because I have something else to do after this is done. Alright, see ya.